Hello, everybody. Welcome back to another video. In this video, we're going to be taking a look at a question from the IB Chemistry May 2021 paper. It's paper one, and it's from the HL part of the paper. So this question is a both SL and HL question, I think. I'm not entirely sure, but this seems like a question that would come for both SL and HL students. And I think it's a concept that it is important for both students to learn. So let's take a look at it. In this, they've asked us, which changes produce the greatest increase in the percentage conversion of methane? And then they've given us this equation over here, which is an equilibrium. And over here, we can see that methane is combining with water to produce carbon monoxide and some hydrogen gas. Now, you can probably hear in the background, there is something, and that is a crow, and it hasn't stopped for a while now. So I decided to go ahead and make the video anyway. Hopefully it's not too much of a disturbance. But anyways, let's take a look at this equation. It's CH4 plus H2O, and it's all gaseous, is going to give us some carbon monoxide plus 3H2. I'm not writing the state symbols because it's all gaseous anyways, so it doesn't really matter. But you should always write it when you put it in an exam. So we have four options to choose from. And essentially what they want us to do is to give us we need to give them the conditions where methane is being converted into carbon monoxide and hydrogen gas the most, or in the most optimal way. So we need to get the reactants. We need to get the products. We need to get more products. We don't want the reactants. We need more products. So how can we push the equilibrium towards this side? How can we do that? Well, we can do that in a few ways. And the two ways that they want us to use is one, the pressure of this entire reaction, because it's a gaseous reaction, and two, the proportion of H2O that is available. Now, let's take a look at pressure first, right? How I like to go about MCQs is I play the elimination game. So I eliminate answers which seem unlikely. And just based off of this, I can eliminate two answers based on pressure, and that is A and B. I can eliminate these. These are not right because they say that the pressure should be doubled, but that is wrong. How does it work? How does pressure work in an equilibrium? Let me explain that to you. So as you increase pressure, when pressure goes up, the reaction moves towards the side with the least gaseous molecules. Sorry for my handwriting, but essentially what I'm saying is that when you increase the pressure of a reaction in an equilibrium, it moves towards the side with the least gaseous molecules. Now, in this reaction, which side has the most gaseous and which side has the least? Obviously, as we can see, this side has the least gaseous molecules, right? It has one of each, 1 and 1, right? However, on the side of the products, we have 1 and 3. So we have 4 over here and we have 2 over here. So if we increase pressure, the reaction is going to go this way. It's going to shift backwards. It's going to go towards methane. And that's not what we want. We want the reaction to go forwards. We want it to go towards the products. So it doesn't make sense to double the pressure, because if you double the pressure, you're going to get less of the products. We're going to get more reactants. However, we want more products because in the question, they've asked us what change produces the greatest increase in the percentage of conversion of methane. And to convert methane means to convert it into carbon monoxide and hydrogen gas as per this equation. So we can eliminate pressure. Conversely, when you decrease pressure, or suppose when the pressure is halved, when pressure goes down, the reaction moves towards the side with more gaseous molecules. So when you decrease pressure, when you halve the pressure, the reaction is going to move towards the side with more gaseous molecules. And in this case, the side with more gaseous molecules is our products. So now we have to choose between C and D. And we can do that on the basis of the proportion of H2O. Now, when I was looking at this question, I thought about it in two ways, right? The proportion of H2O. One, if you increase the amount of H2O, that means you're going to upset the equilibrium right now because you're increasing more material on one side. So that is going to push the equilibrium to sort of balance it out. So if you have more H2O on one side, it's going to push to consume this H2O and to make more products, right? That's one thing that can happen. And the second way you could think about it is that if you add more H2O can react with methane. That means methane will become the limiting reactant, if that makes sense. H2O can become the reactant in excess if you add more H2O. And you can ensure that all of your methane is reacting with your H2O and it is going towards the production of the products. Hopefully that makes sense. But in either case, the sort of method to push the conversion of methane towards the products is to increase the proportion of H2O. So you don't decrease it, you increase the proportion of H2O. And that would mean that our answer is C. C is the answer. Hopefully that's made sense. I'm just going to do a quick recap of what I have said. Pressure, when increased, pushes the equilibrium towards the side with lesser gaseous molecules. However, when pressure is decreased, it pushes the equilibrium towards the side with more gaseous molecules. In our case, the side with more gaseous molecules is our products, and our products is what we want to produce. So we halve the pressure, we decrease the pressure. As for the proportion of H2O in the case of this reaction, H2O is a reactant, right? And when you increase the amount of reactants, naturally you're going to produce more products, right? You're going to have more products being produced if your reactants are more. And also, when you increase the reactants in a equilibrium, the equilibrium is going to push towards the side which consumes the reactant, because now you have an excess on one side. So the equilibrium would want to maintain the equilibrium and pushes the reaction to the product side where the reactant can be consumed, or the excess H2O is consumed and it produces the products. Hopefully that makes sense. Thank you so much for watching this video. If you have any questions, I'm always free to help. Message me and I will explain it to you until you get it. Take care of yourselves. Thank you so much for watching, and I will see you in another video with another question. Goodbye.